Hello everyone, I'm Dr. Mehraei, and today we are going to solve a question about chi-square test, specifically goodness of fit test using chi-square. So here we have this question. A coin was flipped 10 times and this was the result. We have 2 number of heads and 8 number of tails. The question is it a fair coin? We want to test it with different confidence levels. So to do that, first thing first, we should come up with our null and alternative hypothesis. So F0 here, it means that we don't know which type of distribution our population, or in this case sample, has. That's why we need to show it with F0. So we want to test it whether it is fair or not. It has a discrete uniform distribution, which means that all the probabilities for all the classes should be the same. So in order to use this formula, we should construct this table. So these are our observed value for number of heads and number of tails. And for expected ones, this is the way that we calculate it. So 1 over 2 is the probability for each one of these classes. So as you can see, 1 over 2 should be exactly the same for number of tails as well, so that we conclude that this is an unbiased coin. And what is 10? This is the number of our trials. So 10, because 10 times we flip the coin, and multiply it by the probability, so you can calculate the expected number of heads and tails. Okay, next thing to do is to calculate your test statistic. In order to do that, you need to use this formula. So observed value minus expected value. For each class, you should do it, and at the end, or at the same time, you can divide it by expected value. You will receive the same result. So 2 minus 5, power it by 2, divided by 5, or at the end, you can calculate them separately and divide all of them by 5. So 2 minus 5 power 2 divided by 5 plus 8 minus 5 power 2 divided by 5, or 2 minus 5 power 2 plus 8 minus 5 power 2 at the end divided by 5, and you will have 3.6. Okay, so this is your test statistic, and based on that, we want to calculate p-value. But in order to do that, as you know, in our table, we need to know about degree of freedom in order to read it from the chi-square table. So what's the degree of freedom in this case? We denote it by V, and this is 2 minus 1, not 10 minus 1, because it depends on the number of classes that you have. You want to construct new classes, new categories, so that based on them, you count the number of observed and expected values. That's why instead of using your number of trials here, we should be careful. For degree of freedom, we should consider the number of classes, number of categories. So this is 2 minus 1, which is 1. So 3.6, 1. Based on these two test statistics and degree of freedom, we should be able to know the region of our p-value. So degree of freedom of 1, it means that the first row. In the first row, 3.6, this is between this number and this number. So if I want to read the p-value, it should be between 5% to 10%. Okay. So p-value is between these two numbers. And what is my alpha? Alpha is 1 minus confidence level. So for each item A, B, C, it differs. So my alpha here is 1%. And if I compare it with our p-value, I understand that p-value is less than 10%. So alpha is exactly 10%, which is more than our p-value. Whenever your p-value is less than your alpha, this one implies that you can reject H0 with a certain confidence level, which is here actually 90%, not 95%. There's a typo here. It should be 90% because we calculated alpha by using that. So here, please change it to 90%. So reject H0 with 90% confidence level. Okay, so for the next one, we have 99% confidence level. So here alpha should be 1%, and my p-value, as I know, this is between 5% to 10%. Even if you consider the smallest value for p-value, which is a little more than 5%, this one is greater than your alpha. So in that case, you cannot reject H0. There are not enough evidence. So we accept H0 with 99% confidence level. So you see, based on your confidence level, you may reject or accept your hypothesis, which is the same hypothesis on the same trial. So you see, that's why your confidence level is important. As you increase your confidence level, it's getting harder to reject H0. So this is the whole point to calculate p-value, because we want to see what is the value that's less than that we will reject, or more than that we will accept that value. So p-value should be less than alpha. So what is the biggest value that we can reject your null hypothesis? So this is the whole point of calculating p-value here. So for the item C, we have 99.9% confidence level. So 1 minus 0.999, which is 1 over 1,000. And when I compare this alpha with p-value, this is the smallest one, and p-value is even more than that. So you can see it is much bigger than 1 over 1,000, and there are not enough evidence to reject our null hypothesis. So guys, you should practice with different examples, especially in the book that are provided, so that you get used to such examples. As you can see, it's very easy to deal with that. So you should first construct the hypothesis. Then this table is important in order to calculate based on this formula, and you will find your test statistic. And based on test statistic and degree of freedom, you can find the p-value. And by comparing it to the alpha, then it's easy to see whether you should accept or reject your null hypothesis. I hope it was a useful tutorial for you. See you guys soon.